to another exciting day in mathematics. Warm up 109 should come up on your screen as soon as you log in. Let's get started, please. We don't have a lot of time today. We are moving on, so stay focused. Let's go. I'll give you guys some time to copy that. Go. All right, let's get this show on the road. What'd you get for mu? Check with your neighbor, please. Then we're going to get started with Cole. He's going to get us started with mu. All right, Cole, what'd you get? What is it? 30? 30? Hands if you got 30 for mu. All right, looks about right. We need a variance. Check with a neighbor, and then Cole's going to pass someone for the variance. All right, Cole. Brandon Daugherty, what'd you get for the variance? 414. That's funny, like, you guys got here and you're, like, really talkative right now that I'm asking you to share with your neighbor. Everybody gets quiet. What? Say what, Mr. Q? All right, looks pretty close, yes. We need a standard deviation. Check with your neighbor what they got for standard deviation. And everybody's quiet. That's funny. You guys are funny. A long weekend? Be nice. All right, Brandon, pass someone. $20.3. Hands, we got something like that. That's about right. So that leaves us at the variance, the normal range. We are at 50.3 on the top end. On the bottom end, we are at 9.7. So from 9.7 to 50.3. All right, we need a z-score for number 13. All right. Pass someone, Mel. Z, what'd you get for the z-score? Oh, I get it, Z. That was good. Negative. .83. That means close to the -1, so it's about right there. All right. And last but not least, what is our range, everyone? What is our range? 54. All right. All right, well, let me send you the screen so you can send me your notes. All right, so in the agenda, we got warm-up 109. We just completed. We're in the middle of discrete probability distribution. We actually had a pop party on Friday. Those of you that weren't here, you missed it. However, at the end of this period, you will have a chance to take it. Those of you that need to retake it, you studied over the weekend. Very good. Turn to your neighbor, let them know how much time you spent studying over the weekend to retake it. All right, from there we got mean, variance, and standard deviation of binomial probability, which is today. We are moving on today. And 6 problems only for home play. All right. All right, so access to the home play. There's a code, 8GQTS, 8GQTS, write that down, 8GQTS. All right, so get a Cornell note going, please, so we can move on. Today's going to go pretty quick, so stay focused. Our objective for today, I can define and compute the discrete probability distribution. Discrete probability distribution. Once again, I can define and compute the discrete probability distribution. So, by now we are experts at all those probabilities, yes? Yes, Mr. Q. Then we are experts at these variables, discrete versus continuous, yes? From there we introduce a discrete probability distribution. Tell your neighbor what makes this, what's going to make it a probability distribution. What makes it a probability distribution? All right, good. What makes it a probability distribution, Diali? What would make it a probability distribution? Yeah, the probability has to equal to 1. All the probabilities at the end, when you add them, equal to 1. From there, I gave you guys formulas for that probability distribution for the mean, variance, and standard deviation. You guys remember those? Yes? Yes, Mr. Q. From there, we got into binomial distribution, and I gave you guys different situations. And what was so special about all of those? That the outcomes are how many? 2. That's why I say binomial distribution. From there, I gave you guys the formula for binomial distribution on how to find the probability for that. That brings us to today. Today, after we did practice last week for binomial distribution, we're going to find the mean, variance, and standard deviation for binomial distribution. So go to your formulas, write 3 more down. Bam, bam, bam. Write those down, please. All right, here we go. So, everyone, what is this? Mean, variance, and... All right, so far so good. Turn to your neighbor and let them know what this stands for. What does that stand for? Let's see, Dayali, pass someone. Mia, what does N stand for? Yeah, total number of outcomes. Yes, all right. Next, what does P stand for? Tell your neighbor, and then Mia's going to pass someone. Remind your neighbor what P stands for. All right, pass someone, Mia. Brandon Darty. That is correct. Probability. Forget that little thingy right there. Of success. All right. So what does this one stand for? Tell your neighbor, and then Brandon's going to pass them one. All right, Brandon, pass someone. Z. That is correct. Probability of failure. All right, so now that we have all our terms, copy this problem down, please, on your paper. Example 1. Copy it completely, please. And it reads, a coin is tossed 4 times. Find the mean, variance, and standard deviation of the number of heads that will be obtained. Copy this one at least so you can have this one example for this session complete. I'll give you some time. Go. They want us to find the mean, variance, and standard deviation, which means we need all our values. Is that correct? So I want you to write on the side N, P, and Q. So like that we can get this show on the road. It's going to go fast, so stay focused. So, turn to your neighbor, let them know what N is according to that problem. Bless you. All right. Vanya, what is N? Yes, 4. Next, what is the probability of flipping the coin and getting heads? Pass them one, Vanya. 50% in decimal form is 0.50. That's a success. And what is the probability of failure, everyone, of not getting the heads? It's a 0.50 as well. So now that we have our values, let's find mu. Mu is n times p, so that is 4 times 0.50. Calculators calculate. What is that? What is it? 2. All right. Next, let's find the variance, which is 4 times 0.50 times 0.50, which is what? Call 1. And of course, for the standard deviation, everyone, what is square root of 1? 1. That is correct. From 1 to 5, how comfortable are you with this? 5 fours, 5 fours. All right. Send me your notes, please. There it is. Number two reads, a die is rolled 480 times. Find the mean variance standard deviation of the number of 3s that will be rolled. Don't copy the problem for this one. Look up. Write example 2, and I want you to write N, P, and Q. So according to that problem, tell your neighbor what N is, what P is, and what Q is. See if they figure it out. Once again, of rolling a 3 on a die, one die. What is N, P, and Q? All right, let's see. Go here with Alessandra. What is N? Yeah, 480. What is the probability of rolling a 3 on one die? Help us out, Max. One what? 1 over 6. That is correct. Which means the probability of failure, everyone, is, 5 sixths. All right, so now that you have your N, P, and Q, find me mu, variance, and our standard deviation. Give you guys a head start. Go. Good communication. Let's start with Lulu. What'd you get for mu? $80. Hands if you got 80. Looks about right. And once again, that was 480 times 1/6 becomes 480 over 6, or 480 divided by 6. That gives us 80. Okay, not bad, not bad. We need a variance. Pass someone, Lulu. Brandon Doherty, what's our variance? 16 point. 66.6 approximately. Hands if you got that. Looks about right. So we need a standard deviation at the end. Pass that to someone, Brandon. What is it? 8.60? 8.6. 15? 16. All right. From 1 to 5, how comfortable are you with this so far? 5, 5, 5, 4s. Okay, we got this. Let me send you the screen so you can send me your notes. All right, thank you guys. Appreciate it. Look at this next one. Oh, there it is. I just sent it right now. Send it in, please. All right. You all right over there, Aleshka? You good? Okay. All right, let's move on to the next one. Look up to the screen. Don't copy this one. Look at it. Let me read it out loud. It says, example number 3, the statistical bulletin published by Metropolitan Life Insurance Company reported that 2% of all American births result in twins. If a random sample of 8,000 births is taken, find the mean, variance, and standard deviation of the number of births that would result in twins. So, for this one, we're not going to do this one, but I do want you to tell your neighbor what is N, what is Q, and what is P in decimal form. Talk to your neighbor. What is each one of those? N, P, and Q. What are N, P, and Q? All right, write it on the screen, please. Send me your answer. What is N? What is P? What is Q? Write it on your screen, please. With that said, home play on your screen. Work with someone like that. You can deviate the work. For number 1, only do number 1, A, B, and C. Don't worry about D through H. Just A, B, and C for 1. Divvy up the other ones, and if you notice number 3, we already did in the notes. Is that correct? Oh my goodness. Wow. All right. I'm going to stop the video right here for those of you that are following on YouTube. And then I'm going to check up on you guys here in class like in 7 minutes to see where you guys are at with the work. And ETA for the retake of the pop parte would be in 10 minutes. 10 minutes.